We've been doing is testing masks and seeing how they fit. And the gold standard, at least in the United States, is the N95 mask. And unfortunately, there aren't many of the N95s left, so what people have had to do is resort to what's called the KN95. And this is the Chinese version of the N95. So we've tested a whole different variety of these types of masks and found that in general the fabric works equivalent to the N95, and they're very efficient, they work very well, but where they do fail is they fit very differently on the face. So what we've been working on is using this instrument called a PortaCount, and what it does is it samples inside the mask, so that's what this fitting is for, how many particles are inside of the mask versus outside of the mask. So there's two tubes, the blue one samples outside of the mask and the clear one samples inside the mask. So by knowing the ratio of the particles inside to the outside, we can tell the efficiency as it fits on the face.
So one of the things that we've been looking at is a variety of masks, homemade masks, masks that have been made by professors at Tech using 3D printing, some of our students. And really what it came down to was how they fit on the face. And one of the things that we were looking at is could we modify the fit so that they actually worked efficiently. And one of the trouble with these hard masks, in fact this one was bought on the internet, is that they can't be modified to fit a changing face. So if your face doesn't conform to the mask, then it won't work. So these KN95 masks that we've been getting, mostly from China, and in fact a lot of people have been buying these masks to use at home, the general public. In fact, even my parents in London have bought these masks to wear out, is that even if they work as efficiently separating the particles, if they don't fit your face correctly, then you actually end up not protecting yourself the way you think you would. And so we got into this, and the nice thing is I can actually see what goes on as far as the particles getting in and out by watching the screen when we analyze these. But the masks tend to come in these varieties that hook behind your ear. And so when you put them on and you just kind of push them to your face, one of the things you'll notice is that you actually, when you breathe in and out, the mask actually leaves your face, which means particles are getting in. And so, in fact, if I inhale now, you can see the mask comes in, and I push it out and it goes back. Well, I can actually feel the air hitting my eyes as I exhale, which means that it's not conforming to my face.
Everybody's face is a little bit different, and where you can find are common areas of failure, and it's usually at the bridge of the nose. Right? That's a very common place because that's part of your face that's not uniformly shaped. So there's a metal strap that needs to be pressed firmly in to hold it close to the bridge of the nose, all the way down to the cheeks. The other place that is a common source of failure is under the chin. So underneath the chin, you can see when she first puts it on, there's a small gap, and that's going to allow air to come in.
And so one of the things during these tests we were trying was to see if we could actually make them work efficiently. And so I ended up making sure that they were really tight. Now these hooks behind your ears are not pulling it tight enough. So one of the things that we did during this testing was to actually, and it looks awful, but to put them behind my head very tightly. And in my case, that was putting them behind my ponytail. And so it looks horrid, but once it's this tight, it actually protects you. And we could show on the screen that now the particles aren't getting in and out. And so that was how we made these masks pass this fit test. And it actually makes breathing kind of harder, but there's no particles getting in the top or underneath through your chin. Now, not everybody has a ponytail, so obviously you can't do this. So one of the things our students here at Tech have been printing, and other groups around the country, are these kind of clips that go behind your head. And so you can actually clip the mask on much tighter than you can behind your ears. And so it makes it slightly more comfortable to do it this way. And kind of pulls it much tighter, and now I don't have the same feeling when the airflow comes out. And so it makes it work much more efficiently. So we've been evaluating these masks for what we call a fit test. And in this process, we actually have to do a series of movements to ensure that the mask fits uniformly across the face through a series of procedures. So shaking your head, bending over, nodding. And one of the often times where it fails is actually in the up and down kind of nodding your head motion. And that's again because the two kind of weaker points are on the bridge of the nose and under the chin. And a couple of times when you lean forward, because then the mask falls away, especially if that fit to your face isn't as tight as it needs to be. And so in this fit test, we can actually see the number of particles entering. So when I'm doing the test, I actually see in real time whether the mask is working for it, as it should for that given movement. And so we try and modify the fit to make sure that we get that uniform fit through the series of motions that we have to take, that we have to do.
What we're doing now, she's hooked up to the instrument where the blue tube's sampling the air right outside of the mask and the clear tube sampling inside of the mask. And from there, it makes a ratio of the particles outside to the inside, and the higher the fit value, the better it is. Okay? So in this case, you can see that the fit is not very good. And now as she increases the tightness, there you go. So you can see how the fit factor goes up. And what we're aiming for is to get around this value of 100 or better, which she's at now. So now she's working at about 1 particle inside the mask for 100 outside. As you see, as it fits even better, she can get up to 200. That's the best that you can do with these masks, is 1 particle inside the mask for every 200 outside. So that's exactly what we're looking for. But you can see the difference. Although it looks just about the same, you can see the difference of the fit factor on this video, which is much better than qualitative fit tests where they look for smell or taste or other things. The whole point of this is, although the mask, the material is protective equivalent, or in some cases even better than an N95, if it's worn incorrectly, it's providing little more than just a standard cloth